Hello viewers, greetings and salutations. My name is Nick Hodge. I'm a developer and a geek. My email address is nhodge@munja.com. My personal blog is nickhodge.com. And the code snippets that we'll go through today, so that you can sort of take and do some experimentation over the weekend, is in my GitHub. So github.com/nickhodge, but there's a gist there. Now, you understand, does everyone know what GitHub is? Okay, source code repository, generally open, more for open source, collaborative sort of projects. GISs are just for short little snippets of code. So rather than putting the full project up there, you just put short snippets, but we'll do that. It's my best side. Actually, I'll do the side that I've had Botox on, but that's a different story for a different day. Great. So, who am I? I've been in the IT industry for about 28 years, and believe it or not, mostly as a non-dev, so working as in environments where my job wasn't doing software development, but I've always wanted to do it. I've worked for Apple, Adobe, and Microsoft. My tenure at Microsoft finishes the end of this month. Sadly, not by my choice, but these things happen. So I will be independent, like you guys, or doing development sort of stuff, hopefully full-time by the end of this year. The last couple of years, I've been doing a lot of app development, application development, mainly for Windows 8 and Windows Phone style applications, but also doing stuff with Windows Azure. Usually fast, rapid built applications, rapid deployment into the stores for various business functions. I've done business intelligence stuff, gathering data from some of our internal systems, massaging the data and posting it into Azure tables, and doing all sorts of weird and wonderful sort of programming things over the last 2 or 3 years. But my job at Microsoft was an evangelist, which is actually a non-programming job, but I try to do programming, which is probably one of the reasons why I don't have a job there anymore. But let's not go down, let's not spend too much time on that. I also contribute to open source and in C# as a language, and I am a fan of functional reactive programming, which is the topic of today. So I'm here because Adam asked me to be here and let me have a topic of my own choice, and because I'm a fan of this, independent of where I work and what I do, I think this is a cool topic to actually talk about and explain how you guys can use it in your future programming tasks. As I was explaining to Gary earlier, functional and reactive programming is not something that you apply everywhere. So it's not something that you have there's an old adage that when you have a hammer, everything looks like a nail. Reactive programming is not like that. It is not that it's something you've got to hit everything with reactive programming, but there are certain cases, certain use cases, certain business cases where it is useful, and I'll show you those. So this is a very, very simple, two-line piece of C# that says the HTML, which is going to be a string. I was hoping you'd just take my word for it, but that's a little bit better. Okay, so I'm just using LinkPad here, and this is this string is going to be fetching this web page from a URL, and then writing the first 10 characters of that out. So it's basically getting the string and taking the first 10 substring of that, the first 10 characters, and it's going to output it. This, I'll just run it first, and then I'll show you what this function looks like. So run. Okay. My extensions is there. And okay, I just have to include in this. I've changed the name. Well, I'll show it this way first, and then. So my fetch web page takes a URL, and using the web client, it downloads that string and returns that new string back to the calling function. So it's called web page, fetch web page simple, and run. And so it just shows the first 10 characters, which is just the doc type on the HTML. That's all. So it's done this synchronously. So synchronously, it's the program is called into that function, going to get the web page, gets creates the web connection to the web server that sits above my desk at home, somewhere down the road, gets that data and returns it as a string, chops off and only shows the first 10 characters and displays it on here. So it's quite simple. Okay, that's what that code is doing. But we can, as you have learnt earlier, we can do some interesting things with link. So here I have an array of strings, and each of the strings is a URL. And I'm going to say my results monad, my results array, is going to be going to the websites, and for each, or then selecting for each of the strings that are passed in, so one for Google, one for Yahoo, one for Bing, run that web page simple from that URL, and then just dump out the results. So this just runs the exact same code, and I wait for all of the data to return, and I have my 3 items. So it's gone to each one of those 3 and downloaded it. Quite simple, okay? What I can do with reactive extensions is I can execute the query and watch for the result. Execute the query and watch for the result, execute the query and watch for the result. So I can make the 3 fetching the web pages observables. So in this instance, I'm using a slightly different function here called fetch web page, which is listed at the top, which instead of just returning the string, what it's going to turn is a iObservable, an interface to an observable of type string. Pass in the URL, makes the new web client, it downloads the string asynchronously from a URL, but creates an observable. So that observable is basically setting up something, a monad function that will be executed later when I try and query on it. So I'm saying, create this thing, an observable thing, but don't do the observation, don't do the execution until later when I touch it, and then it will then go and execute. So the code, the only difference of the code between these two is that I'm returning a iObservable of type string, and I'm returning an asynchronous task and converting that to an observable. And I'll show you how to include where the libraries for this come from in C#. So if I just delete this for a moment, Control X, and do dump, oops, results dot dump. Now Adam told me you guys have used LinkPad before, so you know, yep. And I run this. What it's doing is it goes for each of the websites, it makes that observable, and then from that observable selects the URLs, and essentially when I do the dump of the results, then it goes and queries each one of the URLs and returns them to my page. I think I'll just do this very quickly, and then I'll come back to this download example. Just do another example. Who here has heard of fizzbuzz? 2. Okay. One of the things that our industry does is to gauge the ability for someone to code when you do a job interview, they give you programming challenges. And there's lots of books on the internet, lots of sites on the internet that have all these different coding challenges and how to resolve them. One of them is a challenge called fizzbuzz. Basically, it says write a program that iterates from 1 through to some number. If that number is divisible by 3, write fizz. If that number is divisible by 5, write buzz. If it's divisible by both 3 and 5, write fizzbuzz. So this is a way to solve it. So for each S being a number in the enumerable range 1 through 30, so here I'm just using link to create an enumerable of integers from 1 to 30, apply this function, this action called fizzbuzz on that S. And this action takes a long, you can think of an action like a function that doesn't return. So it's a variable, but it's actually a function that doesn't return anything. Functional programming. So take an action, a function, that takes a long, as an integer, a long or an int, doesn't really matter, named fizzbuzz, so it's the variable name, and then create an anonymous method where I take that number, write a dash, and if x, that number, is when you divide by 3, so x mod 3 or x divide by 3, the remainder is 0. That is when you divide x by 3. You get the idea of mathematically what that is. Write fizz. If it's 5, write buzz, and then just do a write line. So when I run this, it just runs very quickly, fizzbuzz, and then at 15, as you'd expect, it writes fizzbuzz because it's divisible by both. Otherwise, it just works down. So it's a very quick challenge, a very quick test for you to see how you would write this. And there's lots of different ways to write it. This is just one way to write this particular solution. And developers and hiring developers use this as a mechanism to see what you're comfortable with in programming. And as you can see here, they can see I've done a bit of link, I've done an action, so a little bit of functional programming, I understand the mod, so they sort of understand my level of skill. We can also write fizzbuzz as a functional reactive program. So I've got the exact same function here. So there's absolutely no difference here with the action, the function that takes a number along and then iterates through it and fizzbuzz. But instead what I'm going to do is create an observable range, not a numeral range, an observable range from 1 to 30. And I'm going to subscribe to the results. Now you can think of this observable range as the stream of data, the data that's in motion, the data that's coming externally. And my subscribe is watching that data. So it's watching the numbers come in. And for each one of them, it says take the I, pass it into that fizzbuzz action. If there's an exception, run this. And when it's finished, write done. So there's just 2 anonymous methods here. So if I run it, it will hopefully produce the same results, and with printing done at the end. But the beauty is that I can do interesting things like, on this observable range, I can say, take last 10 and skip 5. Now if I run it here, so it takes the last 10, so that's obviously 20 through 30, or 21 through 30. Skip the first 5 of those, so skip to 26, and then run the function on that. So what I'm doing here is to this observable range, I'm changing the input function, the function that's producing the stream of data. modifying the monad, so to speak, without changing the rest of the code.
Can you explain the subscribe method?
Okay. So with observables, sorry, stand in front of the camera, Nick, is I can create this is probably a good place to do it. I can just create an observable out of anything. In fact, what I'm going to do is create a particular type of observable called a subject that's just going to take integers. So this f is something that can be observed. It's a subject of integers. Then I'm going to subscribe to whatever happens to f, and what happens in here is again, this is link, so dot subscribe, taking g being the number that you get. Just dump that number if a new one comes in. If there's an exception, just dump the exception that's passed through. And then what I'm going to do is that f, I'm just going to pump in a new value 2, then a new value 3, and a new value 4. So if I run this, what happens is this variable, this observable thing called f, which is the observable just has a subject of integers. I subscribe to that f, so when anything new pops in there, I want to, if it's just a new thing that's added, do a dump. There was no exception, so it just kept, it stopped. And then an outline, and then that dump is just console write lighting that number.
It's like a thread, which is listening on to the subscribe.
Yep. So what I can also do is I can go f.subscribe. So I can create another subscribe, taking that number. I'm going to say, take the number, which is going to be an integer, add 10. Actually, we'll make this an anonymous method, which is just using var result equals h, whatever is coming in, times it by 10, then result dot dump, just output that, and semicolon. Okay, so I'm subscribing to that f. I've got two subscribers. I've got two things observing that one subject. Oops, my brackets aren't right. There we go. So one subscription takes it and dumps out the raw number. The other subscription takes that number, times it by 10, and outputs that. So when the 2 is passed in, one of the subscribers just dumps what the number is. The other subscriber takes the number, times it by 10, and then dumps the result. Okay, so I've got one stream of data that I'm pumping values into, and I've got two subscribers watching or observing that data stream and doing two different things with it. Okay? Now, you might be going, well, where do I get this magical library that does all this magical stuff? I'm glad you asked. The underlying C# libraries that does this magical stuff, and so far I've been a little bit theoretical, we'll do some practical stuff in just a moment, is where's the right, it's at the URL at the end of the slides, so I'll just x.codeplex.com. So I don't know how many years ago, some period of time ago, Microsoft Research decided to build the extensions to reactive programming on top of .NET and produce this library called the Reactive Extensions. and it came out of Microsoft Research. They expanded what we had already done, what Microsoft had already done with Link and C#, and built the Reactive Extensions library that you can incorporate into any project you wanted to incorporate it into. The library was, then handed over to a different part of Microsoft who produced, put it into, as something you could download and install. About 2 years ago, the Reactive Extensions were handed over to Microsoft's open source team. So the Reactive Extensions are now open source. That is to say, you can look at the code behind it, and you can contribute to the Reactive Extensions as well. One of the other things that the Reactive Extensions team have also done is extended that into different languages. So, and in fact, historically, it started its life in JavaScript. So they originally built the Reactive Extensions or reactive stuff under a thing called Project Volta, and hence that eel, which is a fish. Electric eels have volts in them. So it's Project Volta. That's the history of the logo. The Reactive Extension started with JavaScript. They produced the C# version, but there's Reactive Extensions available for Python, for Ruby, for Java, for Scala, for Objective-C. So the actual same concepts, this concept of observers and having code, that different bits of code and lots of different places observing data in motion, lives in lots of different languages from this base Reactive Extensions library. Historically, the concept of observables has been part of the object-oriented programming paradigm since the beginning of object-oriented programming and the formal specification of it in the late 80s. So it's not a new invention. It's not like something that's happened in the last 5 or 10 years. The concepts, the thinking, the theory, and the mathematics behind it has come from has a long way. It's only been in the last few years we've had this great open source library where we can easily program against it. We can use our same thinking in terms of Link, our same concepts in terms of C# and just doing stuff and having nicely strong type data to actually do something concrete with it. So to incorporate that into your link pad, essentially when you right click on a tab here in query properties, using NuGet, you learnt about NuGet. The Reactive Extensions is one of the libraries you can just incorporate into your project. There are binaries, there's extensions available for, it works on ASP.NET in the server environment, works on the client side, it works on Windows Phone, it works with the Xamarin toolset in C# when you run it with the Xamarin toolset, producing stuff for iOS and Mac and Android style devices, as well as the RxJS for JavaScript environments and those sorts of things as well. So the library, the Reactive Extensions library, is open source. It's available in NuGet. You can incorporate it into your projects very easily. And that's what I've done here, and I've just imported those namespaces into my snippets, the Reactive Extension snippets. So that's where the .subscribe comes from, and the subject comes from, and the observable. That's all come from the Reactive Extensions library.
And how did you add it into LinkPad?
Right-click on the tab, Query Properties. You then add NuGet. You can just search for NuGet for the library, and you say add that and the namespaces to this project, and that adds it into that snippet you're working on. What you can also do is once you've added it, you can save it default for new queries. So every time you make a new query, it will add them by default into LinkPad. The other thing that I've got in my LinkPad here is my extensions, which I've just got this, where I added in my extensions these 2 download extensions just to do the quick downloading of the page. But that's fairly simple. So let's run this. Okay, you'll see it says slow Google, slow Yahoo, slow Bing. They are too slow. So what I'm doing is creating the observable, but I have a timeout on it saying if the observable doesn't come back to me in 200 milliseconds, cancel it, cut it. And all I had to do was put .timeout there. If I change this from 200 milliseconds to 2000 milliseconds, the results come back. Okay, because the timeout, it gets the data back before the timeout hits, and it just returns the results.
Could you just go back to the definition of fetch web page?
Sure. So that fetch web page in my extensions.fetch web page is in my extensions.fetch web page. That's it here. There is no timeout, retry, or anything in here. There is no exception handling in here. The observables is doing that on top. The other thing the reactive extensions does is it adds some great ways to cache exceptions, but also other things to do the timeouts and retry. So I can run an asynchronous task, and if it doesn't return in 2 seconds, I can just cancel it. Because you're managing that observable. It's like looking at something, and I'm going to look at it for two seconds, and if I get bored, I just look away. Okay, so it's part of the observable that allows us to do that, as well as retrying. Look at it for 2 seconds, doesn't come back, look away. Try again, look away. The reactive extensions, because it's this observable concept, has this built into the underlying framework to do that for us, without changing the underlying code. Okay, did that explain that? I didn't change anything in the underlying stuff. All I is.
I wasn't sure where the timeout was coming from.
Cool, no stress, and thank you for asking, because that is a very good question, and one I probably may have overlooked. What I'm going to do in this instance is slightly different, so I'm just extending the link query even further, where I'm saying defer the observable, so create this observable, but don't run it till later. Just create one that's sort of hanging around. Don't do it just yet, just leave it over here. And it creates one of those for each one of these, puts the timeout in, puts a number of retries in, and then returns this object that's going to get looked at later. And then when I subscribe to it, bang, it gets looked at, and it goes, oh, I better go get this data. Then it goes, gets the data, and executes that, the functions in it, observes the results, and returns them. Okay. In this case, Google will return nice and quick, because Google is fast, but Bing and Yahoo are too slow compared for that 200 milliseconds. So you can see, that was not an advertisement, by the way, it was just stating a fact.
So the thing that makes it lazy is the defer keyword.
The defer, correct. So the defer runs this anonymous method, and that's the anonymous method here, which is just basically returning that return fetch web page. It's just returning this observable that will get observed later. And a little bit more complex here is same with the defer, but I'm going to batch them up. So I'm going to get each of these websites, giving a small timeout, 2 retries. If it's too slow, then catch that and return just that. But just do them in batches of 2, so merge 2 together. So do is two at a time, and then just print the results out. A little bit of parallel processing, but it's not. Yeah, it is, because it's merging, it's running the 2 and merging these 2, but it's the results still come back as 2 separate objects. It's not trying to map them into one object. It's returning 2 separate objects, so it's returning 2 different strings. Okay, so getting Google.com, Yahoo, slow Google, yeah, slow Yahoo, getting Bing, getting yeah, slow Bing, oh, getting NickHodge.com, well, bang, there it is. Yeah, so it's doing it all under the scenes. The reactive extensions underneath is this little virtual environment for dealing with watching things and running things on different threads and just observing what they do, and in different parts of your program, observing what goes on. It's a very different way of writing code. Okay, so let's make this a little bit more concrete. Just before I do that, I'll just function F5. Where was I? So, the core of underneath links are sequences. And a sequence is just stuff or data in a particular order. What reactive extensions does is events. So it's observing an event. It's observing the successful result of downloading a web page. It's observing the successful result of doing the fizzbuzz thing. It's observing another process and getting the result. What I'm going to do in just a moment is, instead of abstract data and downloading websites, I'm going to do it with an application where you type stuff in calling a web service. So a little bit more complex than what we've done so far. Now, in the last 4 weeks, you've probably already learnt about events in .NET. So, have you done, watch for an event on this particular object, if it's a mouse up, and then if there's a click, run this code behind. You've all done that sort of stuff before with C#, an event, have some events. No.
Lots of JavaScript events.
I think JavaScript events, yep. So in JavaScript, when you click on a button, an event is raised and you have a function that handles the result of that click. Okay, so think of it that way. But you don't know what's coming in. .NET has a similar sort of thing. But in .NET, these events are not first-class objects. They are first-class first-class delegates. They allow you to say, when this event occurs, run this particular method over here. So it's what's called a delegate. And you don't really know what's in the data. You just get this object that says the arguments from the event is this. You don't know whether it's a mouse click, you don't know whether it's text that's typed in, you don't know whether it's a move event that's been moved from one place to another. You don't really get the object underneath. You just get this fairly raw thing. And so you've got to write a lot of code to say, the object comes in, is it a mouse move object? Yes, it is. Okay, grab the X and Y coordinates from that object and then do something with it. So you've got to write all this code. And you can't compose these things together. So what I've been showing you earlier with all this observables and retries and passing them around is I'm composing a particular set of functions that run at runtime. With the .NET events in JavaScript, it's very difficult to compose things together. That is, when this mouse goes up and the mouse goes down over here and you've dragged it into this area, run this function over here. That's the way you want to write programs. You want to compose programs with simple things. And it's very difficult to do that. You've got to write state variables. You've got to write, have a variable that says, is the mouse up or mouse down? How many seconds have I been waiting for the mouse to be released if it's a drag? Where did I release? Did I release it in an area that sits over here, which is this part of the page? So you've got to write all this code to actually understand the semantics or the meaning of the events as they stream in. So what's different with C# and with the reactive extensions is we're passing around typed objects. So the objects have type. I've been dealing with simple strings and ints, very simple types, but you can pass around objects that you create of whatever complexity and observe those. They also, you can have multiple subscribers. You saw me do that earlier. I can have lots of things subscribing to it, and I can do link queries over it as well. So where you use .NET events is where you're doing mostly code. You're just doing lightweight UI things. If you're doing very, very simple stuff, normal .NET events are going to be okay. Observables is where you're much, much more centric on the data. You want to do that rich composition, and also you want to have the reactive extensions do all the hard work underneath. So where reactive extensions shines is where you have, as I said right at the beginning, streams of data coming in from UI events or from external web sort of sources or other data in the device. The reactive extensions actually consists of 3 parts. We have this little concurrency engine that sits at the bottom that is like the virtual machine for reactive extensions. That deals with all the threads and the processes and all that sort of stuff, so you don't have to worry about it. So the defers and the run this over here and all that sort of stuff. We then have the streams of events. So these are the, when you subscribe to subjects, whoops, back a page, Nick, you observe an object or you subscribe to things. Then on top of that, we have the event, the link, where we can do the link queries to it over the top. Rather than talk to the slide, I will show you how to hook this up and what this works for. Again, this is in the slides for you when you come and do the review. Review this is that for lists and sequences of data, it's IEnumerable that gets implemented, that you can do link queries on any list that implements IEnumerable with reactive extensions. When you're observing stuff, it's got to implement IObservable, where there's another new value coming in, when what happens with an error, and it's got to implement what happens when it's completed. The sources can be just simple single elements or empty elements, lists and arrays of data, UI events, async methods, which I've been showing mostly, subjects, which I showed earlier, and also property changes. Okay, so let's very quickly, in the slide deck, on SlideShare, I have some extra the source material for this presentation comes from these 3 video sessions. Each of them is about an hour and a half long, so, and lots of code in it. So if you want to go down the next level, they're the sources for that. Extra web sort of sources, both for the for the reactive extensions itself and the code. Using it on other languages, you'll find them in GitHub, including for JavaScript. Some good intros, some examples, and also this book, which I can highly recommend as well. I own that book, and it's a nice book. I have it as a PDF, and I'm still trying to understand parts of it, but it's just a good book to get into this a lot more. Most of what I've talked about so far has been just embodied in one device, in one machine, on a phone or on a computer. It also has applicability in server environments. So the first link here is the reactive extensions at Microsoft is owned by the Cloud Programming team. Sorry, I stumbled on my words. So reactive extensions has an owner that is the people that work with Azure and doing stuff with Bing. Because what in that first video they talked to is that they are starting to work with reactive extensions where there's a server component and a client component. So you can subscribe to things that are happening on a server. So you create a function, and instead of running it locally, you throw it to a server over a network, and it does the function and returns the results, and you observe the results. So if you think about that, where is that used? If you heard about Cortana on Windows Phone 8.1, that uses this technology. And that video there is just a mind-blowing video just to watch if you want to understand where the reactive extensions are going and where they're going and where they're being used. Related to this in the world of cloud is the actor model. It's a project called Project Orleans, to pronounce it correctly, as Michael will probably hopefully correct me, Orleans. Orleans, okay, in English. We have this concept of an actor model where we have lots and lots, we can spread out tasks and processes and observe the results, but it's a little bit more complex than that. But if you're interested in cloud architectures and doing things on massive scale, that's also worth looking at as well. And there's also a reactive extension, so an extension to reactive extensions that works with this as well. I saw yesterday, but I didn't have a chance to go and experiment with it. Okay, so that's sort of some future and some sort of mind-bending stuff. How do we actually put this in practical in building a client application? I'm glad you asked. Yeah, okay. So this is a Windows 8.1 application. It's just a new app, new blank application. I haven't done much with it. I will publish this. I've already published the snippet for this actually up on in GitHub. But essentially, all it does is, have you done any XAML stuff, WPF stuff yet? Okay. So this is good because I will therefore defer, so you can observe this and then later do the later observe defer to actually see what's going on here. Essentially, I've got a text box that you type some text in, and I've got some suggested results. So it's like doing a query into a dictionary to say, if you type in this word, what words match that dictionary entry. I have a web service reference to a dictionary service, which is just out there on the internet. So I've just made it I just right-click, added a new service reference to this ASMX, ASMX, so a web service that returns results. So you just send it data, it returns a result. And when I run this, I'll just run this. Project needs to be deployed before it can be started. Okay, build clean solution, build solution. Oh, build failed. Oh. Okay, so let's just turn off Windows Phone here and unload that project and build the solution. Yeah, build succeeded, run. Okay, let's really trick this up and rebuild solution. And delete it from here. Build solution and run. Okay. So this is just a very, very simple Windows 8 application. Now, in your work with JavaScript, imagine you've got a web service. You've done web services with JavaScript so far, using AJAX calls or calls out to a web service. Yep. So similar sort of thing, except I'm using C# here, and instead of HTML, I'm using XAML. So similar sort of concepts. Normally, when you want to allow a user to live type stuff into a text box, and then take that text, and whilst the page is still on screen, go and query a service and return results, how would you do that in JavaScript? So a user types into a text box.
One way to do it would be to add an event on click, like on change.
Yeah, on text changed. Yep.
And then handle the text. Just read from
Yep. So every time a user types text, it's going to do a query to the service, isn't it?
Yeah. Unless you
So how are we going to fix that? Keep going. There's no magic answer here, so you're doing well.
so let's say maybe you wait a few seconds,
Mhm.
some time.
So you have a timer outside the... So you wait a few seconds because you've got a timer outside the page that says, okay, you turn the timer on when the first thing's typed, and then you wait for the timer to tick down because the users might type some other stuff, and ignore it until the timer clicks, and then suddenly, oh, there's more text there, sort of thing. Is that what you're saying? Yep. And what happens if they delete some text and type the text again?
Basically has to,
It'll do another call because the timer counts down, but they've typed the same text in. So you're probably going to have that hold that text as well. You know, what was the last query of text? And if it's different, then do the query. Otherwise, don't, because you don't want to be polling all the time. You don't on every type of typing a text. So you have the timer and you have that global state, which is the last query that I did. That's how you do it, wouldn't you? Sort of thing. Yep. So in a world of reactive extensions, we can actually be a little bit more interesting. Thank you. You answered correctly, by the way. So here, I'm wiring two things together. I'm wiring the input. So I'm looking at the input, the text that's typed into the text box. And once something is typed into that, I'm going to watch that, and then I'm going to send it to a web service doing a query and get some results back. And once the results come back, I'm going to populate the list box on screen. So the input is create an observable from the event pattern. The event pattern is basically the same as JavaScript events. When you type something, you get that text changed event. The same thing here. I'm watching the text changed event on that text box. So when the text changes, observe that and then run this function. Get the text from that text box. So that the search word here is the name of that text box on the screen. Get the text from it. Throttle this to every 5 seconds. So that timer we just talked about, where you're counting down the timer, again with observable, we have this way of throttling it. That is to just slow down a little bit. We'll wait for a certain period of time, a certain time span. Only look at it every half a second or whatever. In this case, it's half a second. And only fire an observable when it is distinct. That is to say, the text has changed. Okay, so it's distinct until changed. Only show distinct or unique queries after they've changed. So wait for half a second. Is it new? No. Don't fire the observable. Don't throw that observable text out. Yep. So all I'm doing here is creating it, looking at that field called the search word field, which is the text box on the screen, name of the text box, and I'm looking for the text changed event. So I'm saying observe the text changed event on that text box, and then every time that happens, just grab the text from there, but throttle that down to every half a second, and only fire the observable once it's changed. Okay, very, very simple. Then I have a second observable here. Is the results are from the term in input from words in dictionary service, and this is the name of the method that it calls the query out over the network to the dictionary service out there on the internet. It's looking at a particular dictionary name. It's only looking at the prefix of the text, so it's looking for this word at the beginning of the text. And the term is what's passed in here, so that's a term from the input. So every time that input changes, this little result gets fired. Select words. So what it's doing is this is a link query that is called when the input changes, that is every half a second when it's distinct or changed, go and run this query as a function, so functional programming, so that gets fired. And then I observe the results, and this observe on is saying just run it on the user interface thread, because the query is happening over on this other thread, over here. It's running in the background. I want to observe, but on the user interface thread, because I want to pull the data into the user interface thread so that I can put it on screen. I subscribe to the words, so I'm subscribing to this output out of this function. So it's just observing. It's saying whenever those words change, I change the source of suggested words, which is the list. You'll see this in a moment, the suggested words list. Change the source of the items, the things that are displayed, as being this little really weird link query, which is from each word in words, select the word. Basically, you get a list of a list, and you've got what I'm doing is just querying into that list and just pulling out particular bits of data. It's just the shape of the data as it comes back. I've got to do a little bit of magic in link do a little bit of magic in link to pull that out. That's all that's doing. So when I run this, that's all I've done. I've wired up something that's watching the input at the top. I've wired up a query that is a link query that only gets fired when the input changes. So the input changes when observe that. And then down the bottom here, I'm observing changes in the results coming back from the service and updating the list box. So if I type React here, wait half a second, it'll do the query and put the list of results here. So type in reactive, waits half a second, does the query, returns the results. Backspace over the E, type the E again. No, it won't fire because it's throttling. Remember, it's throttling and making sure it's distinct. I didn't change the word. It was not distinct, and not a distinct new word, so it's not going to fire another query. I take the E away, wait half a second, rerun the query. So that's all I've got two. See how the observables have worked, reactive extensions? Instead of programming through the watch for this text to change, wait half a second, create a state that says, hold that state of what I queried last time. If it is, then run this process, go and execute a query against this service, get the list of results back. Then, for each one of the list of results, push it into that list box. Very, what you call imperative programming. You think about the program in a step-by-step process. In this way, I'm just wiring up different things and observing different things, and the output of one thing is an input of another. I observe the stream of results and I push it somewhere else. So it's a very different way of programming. I react to the streams of data that come in, react to the streams of events that the user types in. And that's a practical example of doing that.
In this example, at which point does the timer fire off? Is it when the text is changed, or it's checking every couple of seconds?
When the text changes, because that, good question. If we go back and look at the code here, the input is creating an observable from the event pattern of text change. So every time the text changes, there's an event that occurs, and it's returning, every time the text changes, just the text that's in that text box. So every time that text changes, there's an event, the event is raised, but the observable has been created from that event, if that makes sense. And every time I'm getting this nice string of text, which is the text in the text box. What I'm then doing is saying, after that, throttling that every half a second. So I'm not going to fire, not going to pump something out. I'm not going to create something that someone else can watch. I'm going to wait for half a second. So just slow down a little bit. Just throttle yourself down by half a second. And then it is distinct until it changes. So it keeps the previous state and only fires the observable when the data changes.
So if you typed in two characters in less than half a second, the first one wouldn't fire?
Yep, but the observable would not fire. So the first one fires, yes, but the observable to external watchers will not fire because it's throttled to half a second. Okay?
So it would wait, and if you entered another 3 characters, it would take the last one.
Correct. Yep. Okay?
Yeah, but
Cool.
So how is the service binding to the text box in the third line? I mean, after the dictionary, how are you binding it to the event that once it's fired, run the service?
Okay. So I create this function, which is the results of doing the query, and it selects the word, so it's returning an array of a list of a list. Then what I've got, so it just creates that, but it doesn't execute it. It's again this functional programming. Okay, so it's like a link. It's a monad. It's a thing that just sits there. It doesn't fire. It's just a function ready to be called when something is fired from input. Remember, this one up here is the typing the text in is called input. When something comes into input, then this is executed. So what you're doing is creating a little function that is called later when the input changes. And that is when it's distinct and after half a second. And what's passed in is the text in the text box. Then, when that's fired, then it goes and from the service, take that term and do the query to the backend service. And from that query, just get the list of a list of words.
The last section, shouldn't we be subscribing it to the input rather than the word?
No, because what I'm doing now is observing the results of the query. The list only is valid if the query is successful. If the query fails, or times out, because I could put a timeout on this as well. I could say, timeout after 1 second or whatever. Only observe this once there is output out of this query. So all of the gunk of the network stuff is hidden underneath in the observables for you. So observe, this is just on the UI, on the thread, subscribe to the results, taking the words. So remember that subscribe from that subject stuff I did a little bit earlier? I'm just subscribing to the results of this. And it's only when this executes that this is, great, I've got some words here, a list of things. Then I just set the item source to the, what's in the words. You just dig. Okay? So I've got three little programs here, all separate, but I'm binding them together with observables. Very different way to programming, isn't it? Because they're not running sequentially. Yeah. Normally you think, okay, it's going to this, and this is going to run sequentially. No, it's not. It could be jumping anywhere in this. And what's happening underneath is the reactive extensions is dealing with reacting to the data coming in. So go right back to what I said right at the beginning. When you're dealing with data at rest, it's relatively easy to do the query. You do a query, data's at rest, you get a result back. But with streams of data, you've got data coming in all the time. And as you saw here, the text changing, the data coming back from the web service, it's coming in at different times. So you've got to program differently, and you've got to react to the data with different functions and different things. And this is a case in point using binding UI to a web service in very simple terms, with all the timeout stuff and throttling and all that sort of stuff done for you by the reactive extensions. This is why I'm a fan of it, because it just makes that sort of programming much simpler.
Once again, you're coding declaratively instead of imperatively.
Correct. You're just describing what you want to happen when certain events or certain things happen. Yep. Okay, and for my final trick, that code's in the snippet, by the way, so you can go and have a look at it. I am the first to admit that whilst I've been programming with reactive extensions for about 2 years or so, I am by no means an expert in it, but I do use it in a library that I write that's open source called Boxkite Twitter. It is an API for .NET to access the Twitter API. But it's reactive extensions, so you can subscribe to streams of data, you can create a search term and subscribe to the results using reactive extensions. So I use the reactive extensions underneath to actually do the hard work. So anyway, that's my project where I use reactive extensions, and I use it in lots of different places. I use it, apart from dealing with the streams of data, I also use it in a little state machine. So I observe different events, and if something doesn't happen, I do something else. So if I can't create a connection to the service, I go and run this other thing over here. So I'm using the reactive extensions as a way of storing state and doing different things based on the state of the service at the particular point in time. So that's where I use reactive extensions live. There's about 3,500 downloads of my library so far, which is not very much. But yeah, it's my hobby. It's what I do. Yeah, and so that's it. Thank you.
Did you get all that? We'll take the SSW TV quiz and test your knowledge now.